Hello guys, welcome back to another video. Wow, I sound just like a very typical YouTuber now, don't I? Anyways, I do have something to showcase to you guys. This is my M.adder version 0.3, and it comes with a lot of upgrades or advantages. It depends on how you look at it, but for one, each of the cells are actually smaller, so each adder cell is 4 by 5 by 20, 20 high in the Y level, and then you've got 4 for the X or Z and 5 for the X or Z. And then you've got a new kind of performance upgrade. It actually can be clocked faster now, and I'll show you how fast I can clock it. I'll just show you what I can do with that. And then the major performance upgrade I did was actually reduce the amount of redstone updates. So there's only 9 pieces of redstone dust per cell now, which is slightly lower than a fourth of the redstone dust I used for the version 0.1. So instead of babbling, I'm just going to go ahead and get close to this thing. This is 16 bits just for a demonstration. And it can go on forever as long as you can load the chunks. So yeah, it's no big deal. And yeah, I'll just go ahead and show you how it looks now. So we've got our 2 XORs. The first one's up here, second one's here. And I actually decided to use a vertical XOR gate for this design, just like the 0.1 I believe used an XOR gate. So this one actually takes the vertical one to a new level for me. And yeah, I used pressure plates here to keep the signal from not powering this main piston here, so we have no issues with that. And the check this out. So our 2 carry outs are actually right here for the first XOR and for the second one. It doesn't matter which one pulls first because all this block has to do is be moved up or down, and then the signal gets passed through. Rather, it just shuts off. As you can see, I used cauldrons here. What the cauldrons do is it actually only allows me to have a 3 signal strength here. So this one would be 1, 2, 3, which is actually very good to keep the lag down. And it just basically carries into the next cell. So there's my CN for mainly subtraction. If you want to do subtraction, you use a carry in most of the time for 2's complement. But anyway, so you've got the this basically, there's our carry. Very easy, very simple. And up here I've got some simple, quick inputs, and we're going to go ahead and see how fast our machine will be. So as soon as this light turns off, that one turns on, so keep an eye on that one. There you go. Basically is instant. It's supposed to be. And to make sure the inputs are mostly instant for the most part, all these signals will actually be turned on. But when we select a certain signal, we just turn it off. And as you turn off, you're basically instantly retracting these simple adders here for the XORs and stuff. So yeah, there you go. I did a full carry out, so it's pretty simple. You just do A plus B, and then you just do A's or B's all the way across. Now I'm gonna do something that's probably cooler to see. I'm only gonna demonstrate the addition here on 4 bits because there's no point in me demonstrating it for a large one because I can't render all the lamps on my screen at the same time from the proper distance. So I apologize for that. I'm going to do the first calculation for our little experiment, which is just 15 plus 15, and that should give us 30. 30 will basically be 2 plus 4 plus 8 plus 16, so watch closely, and voila, there you go. It's just 15 shifted over by 1, so yeah. So as soon as I break this, it does its magic. Yeah, I only have delays here to keep everything in sync for the most part, because I didn't want to do a lot of work with a huge testing rig like I showed in the last few videos. I mean, that was just to demonstrate the speed in which you can do your inputs and outputs. Okay, for the next calculation, I'm thinking about doing 5 plus 3. A good old classic problem. So, yeah, so first we want A to be 1, A to be 2, and then I'm going to do, because 1 plus 2 is 3, for B we're going to do 1, and then we're going to go to the cell and do that, and that'll essentially be adding 4 plus 1 for 5, so 3 plus 5 is 8. You'll see that that light's going to turn on. There you go. Just like that. Yeah. Yeah, so overall, I'm very pleased. That's essentially all I wanted to show you. I can't really show you much more with this. I mean, I've covered that in like the other videos. It's essentially the same circuitry, but I flipped it vertically and did a lot of design improvements. So what you're probably going to expect from me now is probably a better multiplying circuit, because now I could just have it this tall, and then on the top I can put the AND gate matrix up there to do all the shift logic, and then the partial products get summed immediately. So yeah, that's gonna be great. And I think I could probably use the cell for the divider I've been thinking about doing. The divider I plan to showcase in the future is going to be one called a restoring divider. But I do plan to do some quick research on non-restoring dividers, since they're faster, and faster is better in my books. So yeah, if you enjoyed, please give the video a like, and I wouldn't mind seeing a subscribe hit there. It'd be nice if you could subscribe if you haven't already, and I'll make a lot of more videos like this. I do plan to very soon make an instant stack project, so that way we can instantly input data into a stack. Anyways, I'll see you later. Bye bye.